This is SpaceTime Series 28, Episode 40, for broadcast on the 2nd of April 2025. Coming up on SpaceTime, the largest organic molecule ever found on Mars. NASA's Parker Solar Probe survives its close encounter with the Sun. And some interesting results from a new study looking at the earliest days of Earth's formation. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists analysing pulverised rock using NASA's Mars Curiosity rover have discovered the largest organic compounds ever seen on the red planet, and they could be the remains of fatty acids. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, PNAS, expands the kinds of ancient molecules that can be preserved on the Martian surface. And it suggests that prebiotic chemistry may have advanced much further on Mars than previously observed. Scientists reached their conclusion after probing an existing rock sample inside Curiosity's mini-lab and found the molecules decane, undecane and dodecane. These compounds are made up of 10, 11 and 12 carbon atoms respectively, and it's thought they could be fragments of fatty acids that were preserved in the sample. Fatty acids are among the organic molecules that, at least on Earth, are the chemical building blocks for life. Living things produce fatty acids to help form cell membranes and perform various other biological functions. Of course, the thing is, fatty acids can also be made through chemical and geological processes using the interaction of water with minerals in hydrothermal vents. So, no life needed. The problem is there's no way to confirm the original source of these molecules, but still, finding them at all is exciting. The Curiosity scientists had previously discovered small, simple organic molecules on Mars, but finding these larger compounds provides the first real evidence that organic chemistry advanced towards the kind of complexity which is required for the origins of life to have evolved on the red planet. The new study also increases the chances that biosignatures could survive and be preserved in the Martian soil, thereby allaying concerns that these compounds would get destroyed and break down after millions of years of exposure to intense radiation and oxidation. So the discovery bodes well for plans for a sample return mission to the red planet, hopefully by the end of this decade. We know the Chinese are planning for that in 2029. But a joint American and European mission has been put on the back burner because of costs. Nevertheless, bringing Martian samples back to Earth would allow scientists to examine them using far more extensive and sophisticated equipment than what can be incorporated in a Mars rover. The study's lead author, Caroline Friesenet from the French National Centre for Scientific Research, says the discovery proves that even today, by analysing Martian samples, one could detect chemical signatures of past life, that is, if it ever existed on the red planet. Back in 2015, Friesenet co-led a team that, in a first, conclusively identified Martian organic molecules in the same sample that was used for this current study. The sample, nicknamed Cumberland by the scientists, has now been analysed many times using a range of different techniques. Curiosity first drilled the Cumberland sample back in May 2013 from the Yellowknife Bay Formation inside Gale Crater. Scientists were so intrigued by Yellowknife Bay, which looks like an ancient lakebed, they sent the rover there before heading in the opposite direction to its primary target, Mount Sharp, the central peak rising thousands of metres from the crater floor. And the detour was worth it. Cumberland turned out to be jam-packed with tantalising chemical clues to Gale Crater's 3.7 billion year past. Scientists had previously found the sample to be rich in mineral clays which form exclusively in water. It also has an abundance of sulfur, and that can help preserve organic molecules. And Cumberland has lots of nitrates, which on Earth are essential to the health of plants and animals. And it has methane, made with a type of carbon that on Earth is associated with biological processes. But perhaps most importantly, scientists determined that Yellowknife Bay was indeed the site of an ancient lake, providing an environment that could concentrate organic molecules and preserve them in fine-grained sedimentary rock called mudstone. The study's co-author, Daniel Glavin from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says there's evidence that liquid water existed in Gale Crater for millions of years. That means there would have been enough time for life-forming chemistry to happen in these crater lake environments. The recent organic compounds discovery was actually a side effect of an unrelated experiment to probe Cumberland for signs of amino acids, the building blocks of proteins. However, after heating the sample twice in Curiosity's onboard laboratory oven and then measuring the mass of the molecules released, the authors found no evidence of any amino acids. But they did notice that the sample released small amounts of decane, undecane and dodecane. Because these compounds could have broken down from larger molecules during heating, the scientists sort of worked backwards to try and figure out what structures they could have come from. They hypothesized that these molecules were remnants of the fatty acids undecanoic acid, dodecanoic acid, and tridecanoic acid. So they tested their prediction in the lab, mixing undecanoic acid into a Mars-like clay and conducting a Curiosity oven-like experiment. After being heated, the undecanoic acid released decane just as predicted. The authors then referenced experiments already published by other scientists to show that the undecane could have broken off from dodecanetic acid and dodecane from tridodecanetic acid. The authors also found an additional intriguing detail in their study related to the number of carbon atoms that make up the presumed fatty acids in the sample. See, the backbone of each fatty acid is a long straight chain of between 11 and 13 carbon atoms depending on the molecule. Notably, non-biological processes typically make shorter fatty acids with less than 12 carbons. But it's possible the Cumberland sample had longer chain fatty acids. Problem is, Curiosity's lab simply isn't optimized to detect these longer chains. The authors say that ultimately there's simply a limit as to how much one can infer from molecule hunting instruments that can be fitted onto a Mars rover. Glavin says they now need to take the next big step and bring Mars samples back here to Earth so that bigger, better equipped labs here can finally settle the debate about life on Mars once and for all. This report about the exploits of the Mars Curiosity rover from NASA TV.
The Curiosity rover set out to answer a big question. Could Mars have supported ancient life? Now we know the answer, but there's still so much more to learn.
I'm Raquel Villanueva, here with Curiosity Deputy Project Scientist Abigail Freeman.
Well, Curiosity landed at the base of a big mountain named Mount Sharp that is made of layers of rocks. So we're climbing the mountain to give us a snapshot of Martian history. We've climbed over 2,000 feet in elevation up the mountain. We're all the way up in these hills now. It's pretty spectacular.
With all that climbing, how is Curiosity doing?
Pretty good, actually. The arm and the drill and the rover, they're a little bit arthritic, and our wheels are a little bit beat up.
And how do you decide where the rover is going to go? Do you work with other NASA missions?
You know, the data from the Mars orbiters have been really helpful. The spectrometers, that's the kind of instrument on Odyssey and Mars Reconnaissance Orbiter, have told us where the interesting minerals are and where the best places to go to look at changing environments are. And then in particular, the cameras on the Mars Reconnaissance Orbiter, they're so good and they're so helpful at allowing us to find the safest way that we can climb this mountain.
What would you say is the biggest discovery your team has made?
You know, Curiosity was sent to Mars in order to answer a really big question. Did Mars have all of the ingredients that we know life needed? And not only have we given that answer a definitive yes, but we've also seen that those ingredients were around for tens of millions of years.
And what's next for Curiosity?
We can see from orbit that we're getting to a place in the mountain that likely records a pretty dramatic change in the sorts of environments that were around. You know, the lakes that once filled Gale started to dry out, and we're getting to that period in time. So we're really interested in answering how long did these habitable environments persist as Mars and Gale Crater went through these pretty big climate changes. I just can't wait to see what's next. We've seen hints that the rocks are going to be very different very soon, and so I'm really curious what we're going to find.
And in that report from NASA TV, we heard from Curiosity Deputy Project Scientist Abigail Freeman. This is SpaceTime. Still to come, NASA's Parker Solar Probe survives a close encounter with the Sun, and it turns out the earliest days of Earth's formation may have been very different from what we thought. All that and more still to come on SpaceTime. NASA's Parker Solar Probe has just survived another close encounter with the Sun, swooping down to within 6.1 million kilometres of the blistering hot solar surface. As well as matching its previous distance record, which was achieved back in December last year, the spacecraft also equalled its previous speed record, clocking some 692,000 kilometres an hour. That's 3 times closer to the Sun and 7 times faster than any other spacecraft has ever flown. The flyby was actually Parker's 23rd science-gathering solar encounter, and each has been getting a little bit closer and closer. This latest flyby allowed the mission's 4 scientific instrument packages to undertake a series of unique observations from inside the Sun's corona during the encounter. Parker was out of contact with Earth and operating autonomously during the close approach. But mission managers at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, say the spacecraft sent back a series of special turn signals confirming that it had survived and was operating nominally. More detailed data and information will be transmitted in the next few days. That's when the probe's further away from the Sun and its extreme electromagnetic environment. The flyby, the second at this distance and speed, allowed the spacecraft to conduct unrivaled scientific measurements of the solar wind and related activities. At the same time, scientists are continuing to dig into the data which is still streaming back from the December close approach. It's all a major effort, with 3 novel aerospace technology achievements critical to enabling Parker to become the first spacecraft to reach inside the Sun's atmosphere. The first of these is an amazing thermal protection system, or heat shield. It's designed to protect the spacecraft from the searing temperatures of its environment, allowing it to withstand brutal temperatures as high as 1400 degrees Celsius. The thermal protection system allows the spacecraft's electronics and instruments to operate close to room temperature. Additional Parker innovations include first-of-their-kind actively cooled solar arrays that protect themselves from overexposure to the intense heat energy while powering the spacecraft, and a fully autonomous spacecraft system that can manage its own flight behaviour, orientation and configuration for months at a time. In fact, Parker's relied on these technologies ever since its launch almost 7 years ago, back in August 2018. Parker's close-up observations of solar events, such as coronal mass ejections and solar flares, are crucial for advancing science's understanding of the Sun and the phenomena that drive high-energy space weather events. So, understanding the fundamental physics behind these events will enable more reliable predictions and lower astronaut exposure to hazardous radiation during future deep space missions to places like the Moon and Mars. This is SpaceTime. Still to come, a new study says the earliest days of Earth's formation may have been very different to what we thought. And later in the science report, we look at the golden keys to being healthy in old age. All that and more still to come on SpaceTime. Scientists have found that planet Earth's lower mantle may have been formed under very different dynamics than what had originally been hypothesized, with evidence of what appears to be low pressure rather than high pressure crystallization taking place. The findings, reported in the journal Nature, shed new light on the earliest days of Earth's formation and potentially calls into question some previous assumptions in planetary science about the early years of terrestrial rocky planets. Establishing a direct link between the Earth's interior dynamics occurring within the first 100 million years of the planet's history and its present-day structure, the work's one of the first in the field to combine fluid mechanics with chemistry to better understand the Earth's early evolution. The study's lead author, Charles-Edouard Beccaret from York University, says the research is the first to demonstrate, using a physical model, that the first-order features of the Earth's lower mantle structure were established 4 billion years ago. The mantle is a rocky envelopment, sort of like slow-moving honey or molasses, that surrounds the iron core of rocky planets. The structure and dynamics of the Earth's lower mantle play a major role throughout Earth's history. It dictates, among other things, the cooling of the Earth's core. That's where Earth's protective magnetic field's generated. Beccaret says that while seismology, geodynamics and petrology have helped answer many questions about the present-day thermochemical structure of the Earth's interior, a key question has always remained: how old are these structures and how did they form? He says that trying to answer this is a bit like looking at a person in the form of an adult versus a child and trying to understand how the energetic conditions will not be the same. Beccari points out that sometimes kids do crazy things because they have lots of energy. But as humans get older, they don't do so many crazy things because their activity levels or energy levels decrease. And so the dynamics become really different. But there are still some things that humans do when they're really young that end up affecting their entire lives. And he says it's the same thing with planets. There are some aspects in the early evolution of a planet that you could still find in their structure today. So to better understand old planets, scientists first need to learn how young planets behave. Since simulations of the Earth's mantle focus mostly on present-day solid-state conditions, Beccari had to develop a novel model to explore the early days of Earth when the mantle was much hotter and substantially more molten. Beccari's model is based on a multi-phase flow approach that allows for capturing the dynamics of magma solidification at a planetary scale. Using his model, he studied how the early mantle transitioned from a molten to a solid state. Beccari and his team were surprised to discover that most of the crystals formed at low pressure, and that creates a very different chemical signature from what would have been produced at depth in a high-pressure environment. And this challenges the prevailing assumptions in planetary science as to how rocky planets form and solidify. See, until now, science always assumed that the geochemistry of the lower mantle was probably governed by high-pressure, high-temperature chemical reactions. But based on these findings, scientists may start to need to account for a low-pressure scenario. Beccari says the work's important because it could also help predict the behaviour of other planets down the line. He says if we know the kinds of starting conditions we have with planetary formation, especially terrestrial worlds, we know the main processes of planetary evolution, and we can then predict how planets will evolve. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that the amount of dissolved oxygen in the world's lakes has declined profoundly since 2003. The findings, reported in the journal Science Advances, shows that heat waves and the overall warming of the climate is contributing to this change. The authors used climate data and satellite images to model how much climate factors have influenced the oxygen levels in more than 15,000 lakes. They found a continuous reduction in oxygen levels in 83% of the lakes they studied, with oxygen levels in the lakes dropping faster than observations in either rivers or oceans. The authors warn lower oxygen levels can disrupt lake ecosystems, harming species living in the lakes and impacting economies on the shore. And of course, deoxygenated lakes produce more nitrous oxide, which can further exacerbate global warming. Well, it's nothing you haven't heard before, but a new study has confirmed that if you want to achieve healthy aging, it's a good idea to eat more fruits and vegetables, as well as whole grains, unsaturated fats, legumes, and low-fat dairy products. The findings, reported in the journal Nature Medicine, looked at data from over 105,000 people across the United States with an average age of 53. The authors looked at specific dietary patterns that help people achieve healthy aging. These include maintaining cognitive, physical and mental health after the age of 70. They found that after a 30-year follow-up, only 9.3% achieved what the researchers defined as healthy aging, with specific dietary patterns being closely associated with that healthy aging. Now, in contrast, they found that eating more trans fats, more salt, more sugary beverages, and lots of red or processed meats was all associated with a much lower likelihood of achieving healthy aging. Scientists have developed a way of purifying urban wastewater and extracting valuable products from urine. The new findings, reported in the journal Nature, could be used for a range of applications, including fertilizing crops. The new process involves using an electrochemical reaction to remove urea from wastewater and transform it into a nearly pure percarbamide, which could then have various useful applications, including environmental water treatment, disinfection, and improved crop growth. So the new findings are presenting a new, potentially scalable and cost-effective approach to large-scale wastewater treatment with both economic and environmental values. Well, it looks like scientists may have come up with a practical replacement for lithium-ion batteries. The lithium-ion battery has been a revolution in rechargeable, portable, storable power, primarily because it lacked the memory charging problems of earlier NiCad batteries. However, lithium-ion batteries are a growing concern because of their energy density and flammable electrolytes, with cases often stemming from improper charging, damage or exposure to extreme conditions. Now, scientists have come up with a practical replacement. It's called the lithium titanate oxide battery. Lithium titanate has the advantage of being safer and faster to charge. They use lithium titanate nanocrystals instead of carbon on the surface of the anode. This gives the anode a surface area of around 100 square metres per gram compared with 3 square metres per gram for carbon, allowing electrons to enter and leave the anode more quickly. Also, lithium titanate cells are long-lasting, between 6,000 and 30,000 charge cycles. They're already being used in many military applications, and some Japanese electric cars are now also being fitted with them. But lithium titanate isn't perfect. The disadvantages include lower energy density, resulting in lower inherent 2.4 volts instead of lithium ion's 3.7. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Now, these batteries actually have been in use by NASA and the military for some decades, but they weren't commercial or commercially available because technology just hadn't advanced to a degree that you could replicate as easily as lithium ion. Now, lithium ion has a problem in that if you put a nail through the battery in the back of your phone, it'll have a runaway thermal reaction where you'll have this outgassing of very toxic gases. And we hear about people with scooters. They charge them inside their houses. They leave them on the charger all night. They maybe have third-party batteries, or the batteries themselves have been damaged because on scooters, you're banging on curbs and it's just a rough sort of environment for the battery. And they go off, and if people have died, their houses have been burnt down. And so people are wary of modern mobile batteries, especially if it's very cold, they don't charge. I mean, we heard about cars that don't charge in the very cold American winters. And lithium titanate has a few serious advantages. One, it operates in those minus 20, minus 30 degrees Celsius temperatures, which are very bad for lithium-ion batteries, and they operate at high temperatures as well. They recharge to full in approximately 20 minutes. If you damage them with a nail, or if they get broken in an airplane seat, they will not have the runaway thermal reaction. And then on top of all of that, a normal mobile phone battery lasts about 1,500 cycles before it starts getting to about 80% of its life and, discharges very quickly. We've all experienced a phone that is not holding anywhere near the charge you got when it was new. And of course, you can buy a new or third-party battery. But imagine if you could have a battery that lasted 10 or even 20 years before you needed to replace it. Lithium titanate batteries have a recharge cycle not of 1,500, but of 20,000 cycles or more. There are some robot prototypes from 30 years ago that are still working to this day because they had lithium titanate batteries. So Toshiba is one of the companies that is commercializing this, going to be using it in power tools that use rechargeable batteries. We'll see these things in cars and in scooters. And the company behind it is called propervoltage.com. It used to be known as ZapBat, BATT.com. And they actually have an operating system that can interface with any sort of battery and produce the correct sort of voltage for any sort of application. So it's kind of this universal translator between different sorts of batteries and different sorts of electronics. In the past, you had to match them very carefully and closely together. But with this operating system merged with this lithium titanate batteries, it's going to be the revolution we've been waiting for in battery technology, but it'll still take a few years before it's everywhere. But it's a great example of that famous saying that from William Gibson, the guy who wrote Neuromancer. He said, the future has already been invented, it just hasn't been widely distributed yet. Well, lithium titanate's time is on the very cusp of being widely distributed, and the battery problems of the past 10 years are going to fade away into non-existent. They'll be distant memories.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.